Alright, so let's start on the next concept, which is how do we actually test for a GP? Right, given a general term of a sequence, how do we know whether this is a GP or not? So let's consider this, right? We know that a GP is basically a sequence, right? And what makes a sequence, particularly or especially a GP, is when the terms, so T1, T2, T3, right? The difference between each term is a constant multiple of R, right? So for instance, let's say I have 3, 6, 12, right? Here is times 2, times 2. T1, T2, T3. So what makes a GP uniquely a GP is there is a constant difference between each term, right? So if we take, for instance, T2 divided by T1, we will get 6 divided by 3, which is essentially 2, right? And let's say if we take T3 divided by T2, we will get 12 divided by 6, which is essentially 2, right? So we see that what makes a GP uniquely a GP is that when we take two consecutive terms and divide them from each other, we will always get the constant ratio, or you can call it the constant multiple, right? But we're just going to call it ratio. So just to put it very generally speaking, so for any general term, as long as whenever we take Tn divided by Tn minus 1, so we take the nth term and then we divide away the n minus 1 term, which is essentially the term before it, right? When we divide it by the n minus 1 term, we will always get a constant, right? That's independent of n. And as long as we get a constant that is independent of n, then we know that this is a GP, right? But if we do not get a constant that's not independent of n, that means it has n, then it's not a GP. So let me just give you an example. So let's say I have Tn equals to 4 to the power of n, right? How do we know whether this is a GP or not? So how to tell if this Tn is the general term of a GP, right? It's as simple as just finding out the Tn minus 1 term. So Tn minus 1 can be written as T bracket 4 minus 1, right? And using your laws of indices, we know that this is basically 4 to the power of n divided by 4 power of 1, which is essentially just 1/4 of 4 to the power of n. So if we were to take this and this, right, and we compute Tn divided by Tn minus 1, right, the term divided by the term before it, we will get 4n divided by 1/4 times 4n. And then you realize that these two cancels out, and you essentially get a value of 4. Now this 4 over here is a constant that is independent of n. So since it is independent of n, then we can conclude that this over here is therefore the general term of a GP, which means that a geometric progression actually exists. Okay, so that is the idea behind it, and I hope that it's making sense to you. So this is the concept. Now we're going to practice with this one mastery question over here. So feel free to pause this video right now to read the question and come back when you're done. Okay, so right now I'm actually going to be going through this question, and I just want to mention that if you are looking for more questions just like that, which are more exam level type of standard, because these type of questions are really to introduce you to the concept. But if you want exam type of level questions with my exact video explanation like this, make it super crystal clear to you how exactly the whole entire question is being structured, make sure to go and click the link in the description below for either if you want to get access to my library of more resources, or if you want to join my classes and get tutored by me personally, or which you can just WhatsApp the number on the screen above, and I'll send you more information through WhatsApp. Okay, if not, let's look at this. Now, the sum of the first n terms of a series. So this sum means Sn. Okay, note that this is not the same as Tn, yeah? Tn is the general term of a series, of a sequence. Sn is the formula for the sum of the first n terms. It's given as this. So it's the same approach as the previous video, whereby if we want to prove it's a GP, we need to first find out what is the Tn, right? We need to first find out what is the general term. So same concept as before. We know that Tn is basically Sn minus Sn minus 1. And why is that the case? Because this one is T1 plus T2 all the way until Tn. And then if we are minusing away T1 plus T2 all the way until Tn minus 1. So when we take this, subtract away from this, right, this portion here will actually strike out all of this except for this, which just leaves us with Tn over here, right? So the only thing left is just Tn. So first we need to figure out what's Tn, right, in order for us to use the test above. So Tn is basically Sn, which is minus 9 plus 4n over 3 minus 2. Then I need to minus away Sn minus 1. So I minus away minus 9 plus 4 to the power of n minus 1 over 3 to the power of n minus 1 minus 2. Right, then I first simplify this. So I get minus 9 plus 4n over 3n minus 2 plus 9 minus 4n minus 1 over 3n minus 3. Now note that these two strikes out, and what's left is just 4n over 3n minus 2 minus 4n minus 1 over 3n minus 3, right? And then from here, you realize that you can factorize out, right? Here you have 4n over 3n minus 2 minus 4n bracket 1/4 over 3n minus 2 bracket 1 over 3, right? You can actually take out this. Therefore, from here, you are able to factorize. So you have 4n over 3n minus 2 bracket 1 minus 1/4 divided by 1/3, which is essentially just 3/4. So your final value here is just 1/4 of 4n over 3n minus 2, right? So that is your general term, Tn, over here, right? So now with that said, how do we prove that is a GP? So from this point onwards, from this moment onwards, what we need to do is to use the method above, right? Which is the test of a GP. And the way we do that is, okay, I'm just going to shrink this. Okay, and the way that we do that is to show, right? We need to show that Tn over Tn minus 1 is a constant. Right? We just need to show that. So Tn minus 1 would be 1/4 of 4n minus 1 over 3n minus 1 minus 2, yet again, right? So when we take Tn divided by Tn minus 1, we are taking 1/4 of 4n over 3n minus 2 divided by 1/4 of 4n minus 1 over 3n minus 3. And then you realize that these two will cancel out. And what's left over here is just 4n over 3n minus 2 times 3n minus 3 over 4n minus 1, of which you have 4n over 3n minus 2 times 3n minus 2 minus 1, which can be written as 1 over 3 over 4 to the power of n times 1/4. And then you realize that this one strike out this one strike out this one. So what's left fundamentally is just 4 over 3. So this 4 over 3 over here is a constant independent of n, right? Which is also the common ratio r, right? In case you didn't know that, because we are taking two consecutive terms dividing away from each other, so the difference is just the constant r. So over here we can say that, what's the question asking? The first term and the common ratio. So this one is the common ratio, right? And then what's the first term? So the first term, T1, is basically we sub 1 into all the values of n over here, right? So it's just 1/4 4 to the power of 1 over 3 to the power of 1 minus 2, and you compute this, you should be getting a value of 3. Yeah. So that's the first term, and then the common ratio is this. So that's our two answers, and then of course we need to prove, right? So the proving method is here. So we say that since Tn over Tn minus 1 is a constant independent of n, this is a GP, right? And that is basically for this concept over here. Let me know if you have any other questions in the comments below. If not, in the next video, we'll be diving into a slightly more complex concept, which is convergence of a GP, which we will have quite a lot of questions for it, because it's a very, very important concept that's frequently tested. Okay, so any questions, please clarify now before we proceed. If not, I'll see you in the next video.